Hey guys, so of course my dot cam doesn't want to work, so we're doing a weird funky video like this, but hey, it works. Today we're going to be taking notes on galaxies, so make sure you draw your line for your hashtags for tomorrow and your title, which is going to be galaxies. And we are first going to define what a galaxy is. So a galaxy is going to be a group of billions of stars all held together by, I'm sure you guessed it, gravity. So this means that there are likely to be a lot of planetary systems in a galaxy. If we're just one solar system and we're super tiny and we're in our Milky Way, we are going to, and we've seen them, like scientists have seen all of these planetary systems. So that means billions of stars means a lot of planetary systems. So typically at the center of these galaxies, especially spiral galaxies like our Milky Way, there is a large black hole, which is a basically giant hole of gravity. So it's helping keep these stars in the galaxy. All right, so we have multiple different types of galaxies. So we're gonna look at galaxy shapes, now that we know what a galaxy is. So we're gonna have a spiral, which is going to be pulling stars in. And in the center, there's usually a black hole, and it's usually also rotating. All right, after our spiral, we're gonna have an elliptical, our favorite word, back at us again. So it's gonna look something like that, and it is also rotating. And then we have our last shape, which is going to be irregular. And these are just kind of all over the place. Like just stars. They don't really have a shape, hence the name irregular. They're just everywhere. Just a weird, random shape. All right, if you still have room, obviously keep your notes on the same page. I, of course, ran out, so I'm gonna move to the back page. So our galaxy is called the Milky Way galaxy. Ooh, ripped my paper. The Milky Way galaxy. And it is a spiral galaxy. So we're going to have our little center. And our little solar system is way out here. All right, our Milky Way galaxy is going to be about 90,000 light years wide. Now I'm going to explain exactly what light years are. So light years are used to measure distances in space outside of our solar system. And it's also how far light travels in a year. So I want you guys, when you're done with the rest of your notes, to figure out how fast light travels. So you'll come back to your notes and you'll finish answering this question. Right there. All right. So, talking about how gravity is a force. And it's not the only force acting on us in our solar system. So we have two, if I find my right pen, two main forces acting on the universe. So one is gravity, which we established is a pulling force. But the second one is the energy left behind from the Big Bang. And the Big Bang was like this giant explosion. So that's going to be pushing stars out from the tiny, tiny point where all matter was right before the Big Bang. So energy left behind the Big Bang, and it is a pushing force. So we know that the pushing force of the energy from the Big Bang is making galaxies move. But to figure out how they're moving, scientists use something called the Doppler shift. So it's using wavelengths to determine if galaxies are moving toward or away from Earth. So we're going to take a couple notes on this, and then we'll be moving on. So we have the Doppler shift, which we use to track galaxy movement. So, if galaxies are appearing red, that means the wavelengths that they are emitting are longer, because red is a longer wavelength. So it's going to look like this. So the peak of this wave of light from this wave to the peak of this wave, this distance is called a wavelength. And if it's long like this, a long wavelength, we will see the color red. So galaxies will appear red. And when they're appearing red, they are moving away from the Earth. But if the wavelengths are super short and appear blue to us, that means they are moving toward the Earth. So toward our galaxy. Make sure you're leaving room, unlike me, for your summary. So that means if they appear blue, got our elliptical and our irregular, they are moving towards Earth. All right, make sure you go back and answer this question, and you are good to go on your notes. I will see you all tomorrow. Be good.